Hope you like the new beats. Well, welcome again to Data Beats. Today, Dunith Dhanushka, the dev advocate at Startree, the creators of Apache Pinot, is here to answer some questions about streaming data infrastructure. So here we go. Hey Dunith, thanks for joining.
Hi, Arpit. Thanks for having me.
Yeah, of course. First question for you, Dunith. In simple terms, what is streaming data infrastructure?
Yeah, so before answering that, I would like to introduce you to events. Events comes first before streaming. So basically, events represent facts about what happened in past. So when we sequence these events into a stream, we call it a streaming data infra. The infrastructure you need to capture, process, and make sense or analyze these events in real time.
So, what are the prerequisites in terms of the data stack to set up streaming or real-time data pipelines?
So basically, once you look at streaming architecture or the landscape at a very high level, we can identify so many so many components. So we can categorize them based on their role and their responsibility. So the first thing is producing or enabling events from your existing application. Basically, these can be programming language, SDKs, or middleware that can capture event from your operational systems. And secondly, we need a scalable storage medium to store these events scalable manner. So this is where real streaming platforms like Kafka and Pulsar and these kind of other platforms come in. And then third layer is massaging this data. So we have event producers, and then we ingest them into event streaming platform, and optionally the events landing in this platform needs to go through some sort of a transformation, because uh, this is raw data, right? So it could contain some unwanted information, like you sometimes you need to mask some private data from this data frame, and map JSON into XML and these kind of things, join two streams together and produce an enriched view sort of thing. So this is where you need data massaging, and we can use stream processing. And then finally, you need to have some sort of a serving layer to present or serve this aggregated or processed information into your end users. So this could be internal consumers like your data analysts or decision makers, or it could be external to your business. Sometimes it could be your end users. So in that case, you need some sort of a real-time or OLAP database or a read optimized store for that. So those are the four components, four critical components that you need to have in your streaming landscape. But this could be varied based on the complexity of your use case.
Right. No, that made a lot of sense. So this is a good segue into you telling us what exactly is Apache Pinot and what it does.
So Apache Pinot is a real-time OLAP database. So, so there are two things to note: real-time and one being OLAP. So, what do you mean by real-time? So that means Pinot can ingest from streaming data sources like Apache Kafka, Kinesis, and Pulsar sort of things, and make that data queryable within few seconds. So that's the first thing. And also, uh, Pinot make is very fast to uh, run complex aggregated, OLAP queries, like the queries that scans multiple batches of data and runs, complex aggregations, filtering, and that kind of logic aggregations within ultra-second, sub-second latency. So that means the latency is tuned for user-facing analytics most of the time, and it falls below the 1 second, and it is consistent.
Yeah. Can you give us a common example of user-facing analytics?
Yeah, yes. So if you are familiar with this LinkedIn, and you will get a notification in real time each time someone views your profile, right? So basically, so that feature is called "Who viewed my profile," and Tino is basically it's behind that use case. So so if you see that feature is like a simple thing, but there's a lots of complicated things going on there. So basically, Pino has to ingest real-time click or profile visits from all the front-end devices, and then store them in a scalable storage, and then run queries in real time to answer lots of concurrent users. So, so if you look at the scale of that queries, that means there can be multiple hundreds of thousands of queries executing on this same database.
Cool. Yeah. Thanks. I'm sure most people here have used LinkedIn, and they many people don't realize what it takes to make that feature available in real time. Cool. So can you briefly explain the benefits of a real time OLAP data store like Pino over a data warehouse, a regular data warehouse?
I think there are two factors to decide. So first thing is the latency. So if you compare real-time OLAP database like Pino and regular data warehouse, Pino can consistently produce queries over sub-second latencies. While basically latencies usually fall below zero, usually in milliseconds, and it is consistent. But on the other hand, data warehouses are much tuned for internal use cases like exploratory analysis, BI, and ad hoc querying purposes. So usually the data warehouses produce latencies like single digit most of the time, seconds. Right. So that's one thing. Also, Pino is the freshness of data can be maintained by Pino by ingesting from real-time data sources in real time. Whereas in data warehouses, we usually employ ETL scripts or ETL batch jobs to periodically load data into them.
Well, awesome. Yeah, that makes sense. Cool. So, typically, how big or small are data teams at companies that successfully implement streaming or real time data infrastructure?
Well, that's a bit of a difficult questions to answer. So it always depends, Arpit. So it actually depends on the complexity and the velocity of your data infrastructure. That means how fast you want to process your data and how complex your ecosystem. That means how many components are there in your system. So if I let's say let me take an imaginary example. Let's say you want to build a real-time dashboard with some products. So ideally, you can start with a single data engineer in your team. So assuming that all the ecosystem components are available as managed cloud services. So that's the very first beginning. So, and then as your data velocity grows and your requirements grow, your product grows as well, you can horizontally scale your team. So basically, you can allocate team members based on data sources, stream processing, or based on the capability as well. Like some people can work on the serving layer, and some people can work on the stream processing, and some people can work on the data acquisition. So yeah.
So, how do data adjacent teams like product and growth utilize streaming data that is usually stored in something like Apache Pinot?
Yeah, so we see many use cases related to growth analytics and product metrics. So basically, especially SaaS companies and product-led marketing companies, they used to use Pino to capture and store their product metrics like engagement metrics. For example, the first point is instrumenting their products with some sort of SDKs so they can emit data points as events into a certain streaming data platform, and then we can configure Pino to ingest from that data platform.
Okay.
So we have fresh set of user engagement metrics there. So these engagement metrics can range from simple button clicks and clicks, page views and these kind of things, ad monetization and these kind of things. And then this vast set of data can be utilized for understanding user behavior. So when it comes to user behavior, so this could be like we can run multiple analysis like daily active user count, calculating the daily and monthly active users, and then doing funnel analysis to understand your conversion rates, and this kind of analysis can be visualized by plugging into a BI system. So in that case, Pino will help you to uh, run this analysis in really fast manner, and while the data is still fresh and relevant. So that is where Pino really excels at.
Okay, awesome. Thanks so much, Dunith. Really appreciate it. Last question for you. What is that one piece of advice you have for companies that are just getting started or looking to get started on their real-time data journey?
Yes, that's a very practical question. So real-time analytics is about processing data as soon as they are available. So that means you need lots of things to put into consideration. That means, say for example, if you are processing data pipelines with millions of events coming in per second. So you need a scalable and reliable computing and storage platform or infrastructure to process them and eventually make sense of that event. So it's not a free lunch, and it comes with some sort of a complexity related to that. So you need to keep in mind that so you are dealing with some complicated machinery when it comes to
Yeah.
real-time analytics. But technologies today is it's getting very cheap, and lots of managed services are there, and you can they try to make it more viable for non-technical users as well. But there are certain use cases you need to identify. Let's say all you need is to populate a dashboard on a daily basis. So it can be easily done with either with a data lake or a data warehouse with a simple ETL job. But then again, there can be some complex use cases like anomaly detection, real-time recommendations, and real-time dashboards, and etc. So all these things, all these last three use cases requires a careful planning on storage, computing, and the analytics infrastructure. So basically, they can benefit from real-time analytics. So just to summarize, know your use case better and think of how much complexity and budget you can spend on that just thing.
Thanks again for answering my question and sharing your insights. You have a great day. Help bridge the gap between data people and non data people. Join us on databeats.community.